All right, a few students have asked for another little review of factoring. Not too surprising, this is one of the more challenging topics that we have in Algebra 2. So factoring helps us break up a quadratic, that's something to the second power, and breaks it into its parts, its two factors that multiply together to get us back to this standard form. Now factors can help us because if we know where two factors are, we can turn those factors into zeros and get a nice look very quickly at where this graph is going to cross the x-axis. Now we're going to see this in our upcoming example, so I already know this drawing is going to work for me. It's important to know that we can't always factor every single quadratic. Sometimes it just doesn't work out nicely, and that's okay, because we also have the quadratic formula that can also help us solve any quadratic at all. So if in doubt, you may always use the quadratic formula in order to find what those two zeros are here, and those can help us find a factor. We'll take a look at how to do that as well. So one of the first things I talk about is how in my family there were 3 of us siblings. And my brother came first, my sister came second, she's in the middle, and I'm last. And there were times when my brother and I would gang up on my sister. And we get the 2 of us and we would multiply our powers together and try to gang up on my sister. We just kind of gave her a hard time. I don't know why. She was a nice person. I know that now, but I didn't know that as a kid. So my brother is the coefficient in front of x squared. In this case, my brother is 1. I am the last kid. I'm the constant. I'm 36. So when I multiply A times C, or 1 times 36, I get 36. And I'm looking now for something that multiplies to 36 and adds to 13. When I think about the factors of 36, there's 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And when I'm looking for the one that adds up to positive 13, I'm looking at these two right here, 4 and 9. If I have a positive 4 and a positive 9, 4 times 9 equals 36. Positive 4 plus 9 more gets me positive 13. So once I've found something that works like that, my brother and sister ganging up on my brother and I ganging up on my sister caused her to crack. And she cracks into these two factors that we have, a plus 4x and a plus 9. We can double check again that plus 4x and 9 more x's add to this 13x. Now what's at the beginning and what's at the end stays exactly the same. My brother and I never really changed. My sister's the one who cracked. And so we had to call on someone to help us out to try to figure out what the 2 of us had in common. He worked first with my brother and my sister and said, what do these 2 have in common? What's the greatest common factor I can pull out of there? And he found that they each have an x in common. Well, to find out what they had in common, he was also looking at what made them different. So I need to think about how I get back to this. If I pull an x out of here, so if I have x squared divided by x, I would have an x left over. When I think about this, it's multiplication. X times x is x squared. And I need to think about x times something gets me a positive 4x. Well, I already have an x here and here, but I'm missing that 4, so it looks like x plus 4. Now, therapist had to do the same thing with my sister and me. He kept that same sign going on there and thought about the same thing. What does 9x and 36, what do they have in common? And I'm thinking for the biggest number. They both have a 1 in common. They both have a 3 in common. But they also both have a 9 in common. I can tell because that's right over here. So if he knows that we both have a 9 in common, I now need to think 9 times something gets me 9x. That would be an x. And 9 times something gets me a positive 36. And that would be a 9 times 4. Now we see very nicely that we have twinsies going on here. So down below I'm going to write the thing that is in common, the twins part, x plus 4. And then I'm going to write what I call the leftovers part, the thing that hasn't been used yet. And there's these two parts that hasn't been used. We have an x plus 4, but we haven't used the x and the plus 9. That is our other factor. So we have twins and we have leftovers. And this is our two factors that when we multiply them back together, when we FOIL them, we should get right back up to here. And we can almost do this in reverse steps. X times x is x squared. X times 9 is positive 9x. 4 times x is positive 4x. 4 times 9 is 36. And then when we combine our like terms right up here, they would add right back up to x squared plus 13x plus 36. Another way to check this, and we'll see what this looks like on the graph. I have my original equation right up in here. And in my other one, I want to check to make sure I have this right. So I'm going to type it in just like it is in factored form. In parentheses, x plus 4, second set of parentheses, x plus 9. And when I look at the graph, I should see these two things right on top of each other. I'm going to do a zoom 6, and here it is in blue, and here it comes right in pink. Did you see that? Let me do that one more time so you can see what that looks like. Just got to make this slight change there. There we go. There's the first one. Here comes the second one right on top. So it changed from blue to pink. So since they're right on top, I know I have the exact same graph. Now what we're going to notice is that on the graph that happens to look like this, I can calculate these zeros. We can do that going second trace, find the 0, left boundary and right boundary. There's my first boundary. Here's my second boundary. I'm calculating this first 0, and it tells me that first 0 is at -9. So I have a point here at -9, 0. And my other 0, when I calculate that, is going to be at -4. Now I can tell this very quickly without even doing it, but there it is at -4. Now I can tell that because it looks an awful lot like these two numbers that are here. And that's because our factor and our zeros are related. If I take a factor separately and set it equal to 0, this x plus 9, I can find what that 0 is by getting x by itself. In this case, subtracting 9 from both sides. There is a 0 when x equals -9, and that matches this one right here. I can see I'm going to find the same thing. This -4 comes from here. So let's do another one just so we can do it. We're going to go through it a little bit more quickly. Let's see if we can factor something like 3x squared plus 16x plus 21. I'm going to go through a little bit faster. Again, we have my brother and myself ganging up on my sister in the middle. When you multiply my brother and I together, we get 63. I need something that multiplies to 63 and adds to 16. Let's see, I have 1 and 63. 2 is not going to work because it's an odd number. 3 and 21. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 doesn't work. Let's see. Let's double check at these. I might be missing one. It's okay to go to your calculator for some of this stuff. 63 divided by 6. We're looking for a nice even number. Ah, I did miss one. Looks like 63 divided by 7 gives us an even number of 9. 63 divided by 8, not going to work. Well, luckily, when I look at this, I have positive 7 times positive 9 gets me a positive 63. 7 plus 9 also gets us that 16x. So I'm going to rewrite this with my middle term split in half. 7x 9x, and 21. Now it doesn't matter which order we write these two in, it'll work either way, which is what's so nice about that. Take them 2 by 2, see what they have in common. They don't have a 3 in common. They do both have an x. I would need to multiply x by 3x to get back to 3x squared. Multiply it by 7 to get back to 7x. Drop that symbol right down. 9 doesn't go into 21, but it looks like 3 goes into each of those. 3 times something is 9x, that something is 3x. 3 times something is 21, that something is 7. And again, we have the twinsies showing up, so twins, 3x plus 7. Leftovers, x plus 3. We now have it in factored form. Don't let negatives trip you up. Negative numbers we're going to handle in exactly the same way. So even if I have something like x squared minus x, wrote the wrong thing there, sorry about that. Even if I have something like x squared minus x minus 72, I'm going to follow the same pattern. Again, my brother and I gang up on my sister. A times c equals negative 72. Anything that multiply to a negative number, that means one of them has to be positive and one has to be negative. So 1 times 72, 2 times 36, 3 times 24, 72 divided by 4, 18. 5 doesn't work, 6, yep. 12. 7 doesn't work. 8 times 9. Now I know I'm looking for a negative number, so one column or the other would have to be negative. I don't know which it is. But since I know it has to add to a negative 1, I need two numbers that are one value apart from each other. Looks like I'm going to be using 8 and 9. And as long as, let's see, it looks like I need more negatives because this ends up adding together to be a negative number. If I make that a negative 9, positive 8 plus a negative 9 does get me that negative 1 I'm looking for. And positive 8 times negative 9 gets me the negative 72 I'm looking for. So I'm adding to the right number, I'm multiplying to the right number. I'm ready to split. X squared plus 8x minus 9x minus 72. Taking them 2 by 2, same way as before. X comes out first. That sign drops right down. They both have a 9 in common. Now I need something that is negative 9 times something is a negative 72. Negative times a positive gets me that 7. Negative times a positive gets me a negative value. And yet again, I have the twins. I have the leftovers. Factored form. I have a 0 at negative 8 and a 0 at positive 9. Let's do one more to show you a unique situation. Sometimes there is no middle number. We can just simply do the same thing again, only this time I'm going to have to rewrite it and add in that middle term. If it's not there, we're just going to count it as a 0. I'm also going to do a quick check of everything. I usually tell students a great thing to check first always is a greatest common factor. If I check that first, I can maybe work with some smaller numbers. And I'm noticing right away up here that 4 and 36 are both divisible by 4. So if I factor out a 4 out of every single term, I get something a little bit nicer. Smaller numbers. I like working with smaller numbers. It's a nice thing. And now I'm going to follow the same pattern I did before. My brother and I ganged up on my sister. A times C is -9. I need numbers that add to -9, but multiply to -9, but add to 0. 1 and 9, 3 and 3. I need them to multiply to a negative, so one or the other has to be a negative number. And I see that -3 and a +3 lands me at 0. -3x, +3x, -9. 2 by 2. These two have an x in common. Symbol drops right down. These two have a 3 in common. I again have twins and leftovers. So my twins are x minus 3. My leftovers are x plus 3. And I do still have that 4 hanging out in front. I'm going to make sure I don't forget that guy. There it is, factored form, yet again. Double check on my calculator. I should see zeros at 3 and -3. All right, I hope that helps out. Again, you can watch these videos a few times. Get that pattern of how we're going to always look at A times C. A times C, multiply together, add to B, make B split apart using those two factors that you've found, and then take them 2 by 2, looking for our twins and our leftovers. Good luck, students. We'll talk to you tomorrow.